Welcome for my presentation for Lab 1, Charge Tapes. I am Alexandra Youngrice. Experiment background and principles. In this lab, we'll be creating charge tapes and experimenting with the electric force of these tapes on other objects. We will be determining excess charge on one of the tapes using interactions with other objects such as another tape, my hand, and a neutral object, in this case a book. We'll also be using the principle of force due to gravity, Coulomb's law in relation of the electric and force field, which you can see in the equations over to the right. We will also be using the principle of attraction and repulsion between like and dislike charges. Like charges repel each other and unlike charges attract each other. We will also be using the principle of temporary dipoles. Temporary dipoles are created when a charged object moves close to a neutral object, creating a temporary dipole within the neutral object. Procedure and assumptions. We will create an upper and base tape by taking about 20 centimeters of Scotch tape and creating a handle on one end of each tape by folding over the edge. We will create a charged upper tape by layering it on top of the base tape, which has been put on top of the table, and then removing it quickly. We will be testing what objects attract and repel the upper tape. As mentioned before, this will include my hand and a book, which will act as a neutral object. Then we'll create another upper tape and suspend it between two objects. We'll bring the other upper tape close to it from underneath and observe at what distance the suspended upper tape begins to float. Assumptions that we have to make for this lab include that the atoms in the tapes are uniform and arranged in a perfect grid pattern so that we can calculate the number of atoms in the tapes, and also the tapes can be treated as point charges and that both charge tapes will have the same charge. Expectations and pre-lab questions. I expect that if two upper tapes are brought together, they will repel each other because they have the same charge. A positively upper tape should be attracted to a negatively charged plastic pen because their charges are unlike, and a negatively charged upper tape should be repelled by a negatively charged plastic pen because their charges are alike. A neutral upper tape should attract a negatively charged plastic pen because of the principle of temporary dipoles. Since the momentum on tape B is not changing, we can conclude that the net y component of the force on tape B is 0. The objects in the surroundings that exert mainly vertical forces on tape B are tape A because of the electric force and the Earth because of the gravitational force that points downwards. In order to determine the gravitational force, we need to measure the mass of tape B, as was seen in the equation showed on one of the first slides. Observations and data. The first upper tape was attracted to my hand and the neutral object. The two upper tapes repelled each other. The upper tapes were attracted to the negatively charged pen, from which we can conclude that the tapes are positively charged. The length of the other tape was 20.5 centimeters and the width was 0.022 meters. The length of the upper tape was 20 centimeters and the distance between the tapes when tape B began to float was 0.5 centimeters. Calculations. Using Coulomb's law, I was able to find that the charge on B was equal to 2.36 times 10 to the negative 9th, and the excess charge, which in this case is actually the electron deficiency because it is a positively charged tape, is 1.476 times 10 to the 10th. The ratio of deficient electrons to the number of atoms on the sticky surface of the tape was 3.24 times 10 to the negative 8th. GlowScript. Here is my GlowScript Python program. First I defined the constants, then I calculated the forces, then the charges, then I defined the objects, then I wrote a function to calculate the force fields, and then I made some arrows corresponding to the different forces. Here is the visual result of my GlowScript program. The labels you can see have been added on afterwards and were not part of the original program. Reflection questions. If electrons had positive charge and protons had negative charge, nothing would have changed about my observations, because the like charges still would have repelled each other and the dislike charges still would have been attracted to each other, and it would have changed nothing about the principle of temporary dipoles. It is important to handle charge tapes as little as possible so that there is no electron transfer between objects and that the tapes remain charged. This is the end of my presentation. Thank you for watching.